Hello and welcome again. Today we look at yet another multiple choice question for IB Chemistry. This one says, the complete combustion of 20 cm³ of a gaseous hydrocarbon, CxHy, produces 80 cm³ of gaseous products. The volume reduces to 40 cm³ when the water vapor present condenses. All volumes are measured at the same temperature and pressure. What is the molecular formula of the hydrocarbon? So let's move in and take a closer look.
So let's take a look here now at the balanced equation, or the general equation, if you will, for this combustion of the hydrocarbon. Now we cannot get the balanced equation because we're actually trying to solve for Cx and Hy. So what we do know is that we have 40 cm³ of each of CO2 and H2O. As the data in the question says, 80 cm³ of gaseous products are produced, and then upon condensation of all of the water, you're left with 40 cm³ of CO2. So it means that we've got equal volumes of both gases, and equal volumes means equal moles. Assuming that these two 40 cm³ amounts are 2 moles, then it means that the 20 cm³ of the original hydrocarbon is 1 mole, and we actually have a mole ratio of 1:2:2, or 2:4:4, or 0.5:1:1. So the ratio of carbon to hydrogen is 1:2, because you can see that within every CO2 there's 1 carbon, but within every H2O there are 2 hydrogens. So we'll have to multiply this 2 by another 2 to get 4. So that ratio of 1:2 between carbon and hydrogen, what that does is it allows us to eliminate answer A and answer B from our choices, and we're left with C and D. Now the final answer is D. You see the ratio of carbon to hydrogen in both C and D as 1:2. But remember, the ratio of the original molecule to the two products must be in the ratio of 1:2. And we can establish that by looking at the balanced equation associated with each of C and D. When we try D, we get this balanced equation which fits the answer here. 1 mole of C2H4, 3 moles of oxygen, 2 moles of CO2, and 2 moles of H2O. When we balance the equation with C3H6, and for the purpose of solving a question, we don't need whole numbers. It's easier to put 4.5 here, and you notice the ratio 1:4.5:3, or multiplying by 2:9:6. So a ratio of 1:3 is what you would get between the hydrocarbon and each of the products, which does not match the data in the question, which says 20, 40, 40. So answer to this question is D.